let's take a look at the spinal cord and the nerves and the vertebra and how they all are arranged on this page. So first I'll go ahead and show you a spinal cord section and the nerves in a few angles. So we can start with coloring in the white matter of the spinal cord. And then you can use blue for the sensory input. This is just like the last page. And then red, I'm going to use my red pen, show the motor output through the ventral root. And then pink for the spinal nerve. And then you can see over here the spinal nerve coming out. The spinal nerves themselves are pretty short, they're only about 1 inch long, and then they just start branching like crazy to go to all of their final destinations. And then the yellow spinal cord you can get a hint of from this side angle, the vertebrae. The spinal nerve exits in what's called the intervertebral notch or intervertebral foramen between each. So if medication is going to be put in for procedure, this is also where they head in. Of course, they would be trying to go in here and avoid the spinal nerves. That might be a good thing to add on to our picture. Well, actually, I think, well, yeah, okay. So imagine that if they were going to put a needle for epidural anesthesia, this is where they would be injecting procedures. And that's, now you can understand probably why they would need someone to really bend forward so they get as much space in between here as they can. Okay, so this is the spinal cord. This is the spinal nerve. This is the vertebral body. It can be kind of thick, right? And then padding between each of the vertebrae sits on top of the vertebral body, and it's called the intervertebral disc. It's made of lots of rings of fibrocartilage, and the center of it is somewhat pulpy. So the intervertebral disc, and recalling that that is a fibrocartilage pad. Similar kind of structure to a meniscus in your knee. Okay, now we'll look at the parts of the vertebrae that protect the spinal cord. So when kids think of their spine, they're thinking of the spinous process, right? And the reason that spinous process juts out like it does is it's an attachment point for muscles and ligaments. We'll find that trend over and over again, is that projections on bones, funny little things that stick out on bones, they always serve this function of attachment sites. So then over here, this is the spinous process. Jutting out on the back of these ones. Of course, on this one I've made the spinous process look like a thoracic vertebrae, and on these ones looks more like a lumbar vertebrae. Okay, then you can find another pen. Let's use orange for the transverse processes. And I've left those off of these ones so you don't see that. and it is also an attachment site for muscles and ligaments, and if it's a thoracic vertebrae, for a rib. And take a look at this, where this is the head of the rib right here, and then it bumps against the edge, the transverse process, and it comes around to the front of the body. And then the nerve, an intercostal nerve, goes right in the groove on the underside of that rib, and then little branches would be coming off of the intercostal nerve for all of its variety of functions. And then to note about the rib, notice that it attaches in two places. First it attaches, so the head of the rib to the body of the vertebrae. That's this big round part, the body, and then you can see it from the side. It's very thick. And then right here we have a second attachment site. That's the tubercle of the rib to the transverse process. Then we have a little bit of bone to look at that connects the back of the vertebrae to the front. That is accomplished by this area. We can color it a little bit purple. These parts of each vertebrae are called the pedicle. That word pedicle means like a foot. So it is a projection that connects the front and the back of each vertebrae. And then right here, it's the lamina. Lamina means sheet. And that bone connects the transverse processes back to the spinous processes. Okay, and why is that important? Well, now you notice that there is no place where the spinal cord is not protected by bone. On the front side, it's protected by the body. On the lateral sides, it's protected by the pedicles. On the back side, it's protected by the transverse process, the lamina, the spinous process, more lamina, and more transverse process.